Let's talk about binary search. We are given a sorted array and an element to be searched in this sorted array. We need to find index of this element if the element is present. If the element is not present, then we need to return -1. If there are multiple occurrences of the element, then we need to return index of any of its occurrences. Let's see these examples to get better idea of the problem. So we have a sorted array which is sorted in increasing order, and we have an element 20 to be searched in it. 20 is present at index 1, so our output is 1. Let's see this example. 25 is present at index 2. We are searching for 25, so we return 2. In this example, 20 is not present in this sorted array, so we return -1. Let's see this example. Again, 20 is not present here, so we return -1. In this example, 5 is not present, so we return -1. In this example, 10 is present at 2 locations, so we need to return any of its indexes. We can return either this index or this index. Now please pause this video and try to write down a function that takes an array as an argument, an element x as an argument. This function should return -1 if x is not present in the array. Otherwise, it should return index of any of its occurrences. And this function should be using the fact that array is sorted. Let's first talk about a naive solution that does not use the fact that array is sorted. So a naive solution is to do linear search. We compare x one by one with every element in the array. As soon as we find an element in the array which is matching with x, we return index of this element. For example, here, if we are searching for 20, we'll begin from here. We do not find a match. Then we come here, we find a match, and we return the index 1. In this example, we are searching for 25. We begin from here. It's not matching here, not matching here, matching here. So we return the index of 25 as 2. Here in this example, we compare 20 with all the elements. It's not present, it's not matching with any of the elements. So we return -1. Now this approach requires theta n time in the worst case. A worst case happens when the element is not present at all. For example, we are searching 20, we'll match it with all the elements, and once we reach the end of the array, we realize that 20 is not present at all. And this particular approach is not using the effect that array is sorted. Now, can you please pause this video again and think of an approach that uses the fact that array is sorted and tries to optimize search using this fact. In case you have written a program yourself, please ensure that your program handles all these cases. Try to run your program for all these cases and make sure you get appropriate output for all the cases. Let us now talk about the idea for binary search. In binary search, we first find out the midpoint. For example, in this array, our midpoint is 3. And how do we find out the midpoint? We mark this index as low index and the last index is high index. Our midpoint will always be low plus high by 2 floor. Right? And when we do integer division in programming languages, it always computes the floor. So in this example, if we do 0 plus 6 by 2, we are going to get 3. Right? Now what we do is we compare x with this mid element. So we compare 60 and 40. Right? So first we found out the middle point, which is 0 plus 6 by 2, which is 3. Now we are going to compare array 3 with x. Right, that's what we are going to do in this example. Compare array 3 and x. Now when you compare these two, 3 cases arise. Array mid is equal to x, which is array 3 and x are same. Array mid is greater than x and array mid is smaller than x. Now please pause this video and think what you will do in all of these individual cases. Let us see these 3 examples to understand the 3 cases. When x is 30, you're searching for 30 in this array, 10, 20, 30, 40, 50. You went to the middle, right? This will be the middle of this array, 0 plus 4 by 2. These indexes are 0, 1, 2, 3, 4. 0 plus 4 by 2 is 2. So you will get into the middle and you compare 30 with 30 and they're matching, they're same. So what will you do in this case? In this case, you will simply return mid, right? In case 1, we will simply return mid. And let's now talk about this case when array mid is greater than x. You were searching for 10, you went to the middle and you found that 30 is greater than 10. So what you will do? Since this array is sorted, you can simply skip these half elements. You can skip this element and these elements also. you know that if 10 is present in this array, it has to be here in this part, right? That's what we do in the binary search. And that's the optimization in the binary search. If you are going to the middle and if you realize that the element that I am searching is smaller, I can simply skip the middle element and everything which is on the right side of it, because the array is sorted. If this itself is greater, then everything on the right side is going to be greater. So what we do is we repeat these steps for low equal to the same low, but we change the high. We change the high to mid -1. Let's now talk about the third case. You were searching for 50 and mid is 30. So your mid is smaller, right? That's the third case. So what are we going to do? We know that mid is smaller. It means this element is not present at the mid and it cannot be present at the positions before mid because the array is sorted. So what are you going to do? You are going to skip this whole array. This cannot be present in this part. Here we skipped this part. Now we are going to skip this part and we are going to repeat this process for this array, which means we are going to change our low this time. We are going to change our low to mid +1 and we are going to keep our high as it is. So low now becomes this and high is this. In this example, our high was changed. Low was here and high was mid -1. So that's the idea of binary search. Now please pause this video again and try to implement the binary search yourself. Let's now see the complete working of binary search. The first thing that we do is we compute mid. Mid is low plus high by 2, which means 0 plus 6 by 2. So we get the mid as 3. Now we notice that array mid, which means this 40, is smaller than 60. So what we do now? We change the low value, right? When array mid is smaller, then your element will be present on the right side of this array. It will be present in this particular sub-array only, right? So to search in this sub-array, we change our low to this point. We change our low to 4, right? And now we search in this array with this low and this high. We again compute the mid, which is 4 plus 6 by 2. So we get the mid as 5. And now we again compare array mid with x. So what do we have at array mid? 60. And what are we searching? 60. They are same. So we simply return 5. That's how this binary search code works for this example. Let us now do one more example to get better idea. We have a sorted array 10, 20, 30, 40, 50, 60 and we want to search 25 in it. To search 25, we begin this code execution. We initialize low as 0 and high as n minus 1. So our low is 0 and high is 5, 6 minus 1. We compute the mid as low plus high by 2, which is 0 plus 5 by 2. We get the mid as 2. Once we get the mid, we compare x and array mid. So we compare 30 and 25. And 25 is smaller than 30. So we are going to go to the left half. We are going to go to these two elements. To go to these two elements, what do? We change high. We change high to mid -1. Mid was here, high was here. Now our high becomes 2 minus 1, 1. That's what we do in this first iteration, right? That's what this code does. If array mid is greater, then we change high equal to mid -1. So now our high is 1. So high is removed from here and high is 1. Low was here and high is now here. Now we are again going to begin our iteration in this loop, and inside this loop we are going to compute the midpoint first, which is 0 plus 1 by 2. So we are going to get 0. So mid is 0. And now we compare array mid and x. So 10 and 25. 25 is greater, so it's going to be there on the right side if it's present in the array. So what are we going to do? We are going to move to the right side. To move to the right side, we do low equal to mid plus 1. So low now becomes 0 plus 1, 1. So now our low is 1 and high is also 1. They both are at the same location. Low is also here. Now we are again going to compare. Now we are again going to compute mid, right? We compute the mid. We begin the next iteration because low is still smaller than or equal to high. They are equal now. So when we compute mid, we get 1 plus 1 by 2, which is 1. And we compare array mid with x. So 20 and 25 are compared. And 25 is greater. So what are we going to do? We are going to go to the right half. And to go to the right half, we'll change low equal to mid plus 1. And low is now going to become 1 plus 1, 2. We do not change high. So high remains 1 and low becomes 2. So when this happens, this condition becomes false. We come out of this loop and we return minus 1. If you take a look at this whole process of searching 25, you can notice that if 25 was present in this array, it had to be at this location, right? And this is the location we reached when we were searching, right? This is the location we reached. And at this location, we realized that it's not present here. So then we went to the right half, and when we went to the right half, low and high crossed each other and we returned. So that's how binary search works. It finds the location, and if it's not present at this single location, then low and high cross each other and we come out of the loop or recursion and we return minus 1. So we have talked about binary search. We have talked about its implementation. In the next video, we are going to talk about analysis of binary search.